The ongoing competitions between the United States and the Soviet Union throughout the 20th century involved not only space exploration, scientific breakthroughs in medicine, and the wonders of economic and industrial production, but also the arms race. Today, we will recall how and with what means the United States put an end to the struggle against fascism in World War I, and also created something that remains one of the main reasons for countries to avoid open conflicts and come to the negotiating table. We will explore how a new type of precipitation emerged and how humanity learned to harness incredible, previously unseen power for peaceful purposes to benefit all of mankind. Scientific progress and war are inextricably linked. Manhattan and Trinity, Bikini, Ranger, Little Boy, and Fat Man. How can all these words be interconnected? What do an island in New York, a peninsula in Antarctica, a swimsuit, a public official, and descriptions of people have to do with it? Today, we will certainly find out. The main theme of pop culture, a direct association with Vegas, the Nevada desert, craters that will forever remind us of one of the most significant events, not only in military history, but in the history of humanity as a whole. We will talk about the greatest fear of any person during the Cold War, how Americans invented and implemented the ultimate deterrence method, literally creating the greatest, most terrifying weapon of mass destruction. We'll look behind the scenes at the Nevada test sites and discuss how scientists sparked a revolution, completely changing the course of humanity's journey. This initiated the nuclear madness of the 20th century, which led the United States to become the first nuclear superpower in the world. We'll explore how society's understanding of the end of the world changed, and what every American housewife feared during the second half of the last century. It's the rise of American nukes. The first nuclear tests conducted by the United States were part of the Manhattan Project, which aimed to develop nuclear weapons capable of altering the course of World War II. The first test, known as Trinity, took place on July 16, 1945, in the New Mexico desert. The atomic bombs dropped by the Americans on Japan, Little Boy and Fat Man, were much more different from each other than it might seem at first glance. Little Boy, detonated over Hiroshima, used uranium, while Fat Man, which struck Nagasaki, used plutonium. In the 1940s, the technology for extracting and processing radioactive materials was imperfect and significantly limited the amount of available uranium and plutonium. Despite the impressive industrial power of the United States, this was a bottleneck. More atomic bombs could not be produced than the volume of enriched materials allowed. More details on this can be found in Chris Wallace's book, Countdown, 1945, The Extraordinary Story of the Atomic Bomb and the 116 Days That Changed the World. The uranium bomb was the simpler of the two. In principle, it did not require testing as there were no doubts about its functionality. Plutonium was much more efficient than uranium. Less plutonium was needed for a successful fission reaction and subsequent detonation compared to uranium. However, its physical properties did not allow it to be split using the same method, necessitating a more complex device, which raised questions. In Little Boy, a gunpowder charge inside a shortened artillery barrel accelerated one block of enriched uranium and slammed it into another. This initiated a self-sustaining nuclear fission, leading to a nuclear explosion in fractions of a second. The strong walls of the barrel prevented the critical mass of the chain reaction from being reduced. In Fat Man, plutonium was imploded from all sides by a carefully designed shockwave created by the simultaneous detonation of numerous charges. Calculating such an explosion was much more challenging than slamming one block into another. Moreover, before attempting to use the plutonium bomb against Japan, the effectiveness of such a design had to be confirmed through tests in the United States. The operation to test the bomb was codenamed Trinity. A desert mountainous area for the test was found in the state of New Mexico. Researchers selected a sparsely populated area of about 27 to 40 kilometers for the test. Additionally, the area had to be free of Native American residents due to complexities in the relationship between the leadership of the Manhattan Project, through which nuclear weapons were being developed, and the Bureau of Indian Affairs. Thus, at the end of 1944, it was decided to conduct the tests in the Alamogordo area of New Mexico. This location was on the territory of an air base, though the airfield itself was situated far from it. The bomb was mounted on a specially constructed 30-meter tower. 3 bunkers were set up at various azimuths, about 10 kilometers from the epicenter, where project leaders and research equipment were dispersed. Despite all preliminary calculations and tests, there was no certainty about the bomb's effectiveness. Scientists involved in the Manhattan Project tried to predict how the test would go. Norman Ramsey thought there would be no explosion. Robert Oppenheimer estimated the blast power at 300 tons of TNT equivalent. And Edward Teller made the most optimistic prediction at 45,000 tons. Initially, the test was scheduled for 4 a.m. on July 16th, when most people would be asleep, so that fewer outsiders would notice the explosion. It was expected that the blast would be accompanied by a bright flash, but not so strong as to wake residents in towns far from the test site. Additionally, researchers planned to conduct photo and video recording, which required darkness. Monitoring the weather was a crucial part of preparing the test. The explosion ideally needed to occur in calm conditions, or with the wind blowing in a specific direction. The resulting cloud should not pass over densely populated areas until its radioactivity had diminished sufficiently due to the decay of nuclear reaction products. Leslie Groves, the military director of the program, noted that the Manhattan Project had the best meteorologists, yet they made a mistake, and on the appointed day, the sky was overcast with clouds and light rain, leading the base commander to prohibit flights due to adverse weather conditions. Nonetheless, the project leadership ordered the aircraft to be airborne, though the value of the information obtained was significantly less than expected due to the bad weather. The main task of the observers in the aircraft was to determine the brightness of the flash, to later compare it to the brightness of the bomb that would be dropped on Japan. Postponing the test would have required several checks, and any delay prolonged the war, so the decision was made to proceed with the test. If the radiance of 1,000 suns were to burst at once into the sky, that would be like the splendor of the Mighty One. I am become death, the destroyer of worlds. Robert Oppenheimer, father of the atomic bomb. On July 16th at 5:30 a.m., the explosion of the gadget bomb marked the beginning of the nuclear age. Captured in photographs, the growing fireball reached 400 meters in diameter, and the resulting mushroom cloud rose over 12 kilometers high. Based on instrument readings, the explosive yield of the Trinity test was calculated to be around 20,000 tons of TNT equivalent. The steel tower on which the bomb was placed simply ceased to exist, as did the herd of antelope grazing nearby. A significant crater, nearly 400 meters in diameter, was formed. The flash was visible from 300 kilometers away. This was the first uncontrolled nuclear reaction on Earth in at least the past 1.5 billion years. The stellar temperatures and pressures created at the test site naturally produced a mineral that had not existed on Earth before. It was called atomsite and Alamogordo glass, but the name that stuck was trinitite, often referred to as the glass tears of the atomic age. We knew the world would not be the same. A few people laughed, a few people cried, most people were silent. Oppenheimer. In our time, when everyone has a mobile video camera in their pocket, it would be impossible to hide a nuclear explosion. However, considering the relatively unpopulated test area and the preparations made in advance, the Americans managed to do so back then. Military personnel were stationed in all places from which the explosion could be seen from afar. They were instructed to reassure citizens and say that a large ammunition depot had exploded. This had the desired effect. The general public learned about the atomic bomb only when it was successfully dropped on the first Japanese city in August 1945. That is, less than a month after the gadget bomb explosion during the Trinity project. This marked the end of the war and led to Japan's complete surrender. At that time, no one in the world could counter this new type of weapon, which completely changed the course of world history. The Marshall Islands is an archipelago in the Pacific Ocean, home to a tiny republic of the same name. White sandy beaches, azure shallows, lagoons, and coral reefs with a vast diversity of fish. For 2,000 years, indigenous people lived on these low-lying islands and atolls, which at various times caught the interest of Spain, the German Empire, Japan, and eventually the United States. The US conducted 67 nuclear tests on the archipelago over 12 years. Today, the Marshallese calendar includes 9 holidays and 1 Memorial Day. March 1st, the Day of Remembrance for nuclear test victims. Just as World War II ended, the Cold War began. Although the USSR did not yet have nuclear weapons, US President Harry Truman insisted on continuing nuclear weapons testing and research. The next test site chosen was the Marshall Islands, specifically the Nukes Atoll and Bikini Atoll, which then had a population of 167 indigenous people. They were told a story that for the sake of world peace, they must leave their homeland and, like the people of Israel, find a promised land. Protestant missionaries had previously reached the archipelago. The promised land turned out to be the uninhabited Rongelap Atoll, 206 kilometers from Bikini. Photos show that the people were far from religious ecstasy. They simply had no choice. The islands were occupied by the US, and soon the UN designated the archipelago as a trust territory under US control, and a military base was being constructed on Kwajalein Atoll for overseeing the tests in Operation Crossroads. The United States planned 3 explosions, with the main goal set after deciding to conduct the tests. The goal was to study the effects of nuclear weapons on ships. 95 vessels were assembled at the Marshall Islands: battleships, cruisers, destroyers, submarines, and even 2 aircraft carriers. Among them were several captured ships, including the famous battleship Nagato, which led the attack on Pearl Harbor. 100 tons of dynamite were detonated to create passages through the coral reefs for the ships to enter the lagoon. The vessels were refueled, equipped with standard gear and ammunition, and 5,000 animals, pigs, goats, guinea pigs, rats, and mice, were placed inside for research purposes. The press and guests, including several scientists from the USSR, were invited to witness the capabilities of American weaponry. On July 1st, 1946, the first bomb, Able, exploded in the air above the target fleet, with a yield of 23 kilotons of TNT equivalent. For comparison, the Fat Man bomb, dropped on Nagasaki, had a yield of 21 kilotons, and the Little Boy on Hiroshima had 20 kilotons. For some reason, possibly a defect in the explosive device or a pilot error, the bomb detonated off target, reducing the scale of destruction. Able was an aerial explosion, and observers, military personnel, journalists, and scientists noted its spectacle. The fireball rose into the sky, and the shockwave rippled across the lagoons, impressing onlookers. Many said they saw a radiant dome, initially mesmerizing, but soon sobering them with the realization of its destructive power. One of the most striking effects was the sound. The explosion was compared to a thunderclap, but much more powerful. On July 25, 1946, the first underwater nuclear bomb tests took place. At a depth of 27 meters beneath the target fleet, Baker detonated. This spectacle was very different from what is typically referred to as a nuclear mushroom cloud. The explosion generated a 28-meter high tsunami, which tossed some ships ashore and covered them with sand. Since the fission products could not rise into the stratosphere, they caused severe environmental contamination. Baker was an underwater explosion that struck observers with its uniqueness. People described the giant column of water rising hundreds of meters into the air as a water mushroom. This explosion left an especially strong impression due to its long-term effects. The giant waves crashing onto the ships and the radioactive mist enveloping everything created a sense not just of destruction, but of something unnatural and sinister. The atomic bomb changes the very nature of war, said the observers of the tests. The third explosion, planned as part of Operation Crossroads, scheduled for 1947, was canceled due to unforeseen consequences. At some point, Truman demanded that scientists create a more powerful bomb as part of the arms race. The decision was made to develop the first thermonuclear weapon, which would be the most destructive weapon of the time. Thus began the creation and testing of the first hydrogen bomb, Ivy Mike. The creation was not the work of evil geniuses from James Bond films, but rather real scientists, Edward Teller and Stanislaw Ulam. Teller, a Hungarian physicist who fled to the US from the Nazis, had envisioned the idea of thermonuclear weapons capable of releasing the energy of the sun on Earth since the 1940s. Ulam, a Polish mathematician, joined the Manhattan Project and developed a method for artificially initiating a thermonuclear reaction using implosion. Together, these minds created a true monster. A 6-meter-tall machine weighing 74 tons, more resembling an oil rig than a bomb. Ivy Mike was the pinnacle of engineering innovation of that time, a highly complex mechanism functioning on the principle of thermonuclear fusion. While a typical atomic bomb uses the fission of uranium or plutonium nuclei, Mike derived its destructive power from the fusion of deuterium nuclei, a heavy isotope of hydrogen. Externally, the entire setup looked more like an industrial structure than a weapon. Nearby stood a 90-meter communications tower, necessary for communication with the bunker on the USS Estes, where the launch team was located. And because Mike operated on liquid deuterium, which had to be maintained at temperatures close to absolute zero, an entire cryogenic facility was built to support it, powered by a separate power plant with a capacity of 3,000 kilowatts. On November 1st, 1952, at 7:15 a.m. local time, Mike unleashed its destructive power on the world. A blinding flash, visible from hundreds of kilometers away, lit up the sky. A fireball, heated to millions of degrees, expanded to a diameter of 5 kilometers, engulfing everything around it. A shock wave, traveling at supersonic speeds, swept away everything in its path. Sailors on the USS Estes, located 50 kilometers from the epicenter, felt intense heat. The mushroom cloud from the nuclear explosion rapidly rose, reaching 17 kilometers in height within just 90 seconds and 33 kilometers a minute later. It eventually stabilized at a height of 41 kilometers with its cap spreading to a diameter of 161 kilometers. The power of the explosion exceeded all expectations, amounting to 10.4 megatons of TNT equivalent. The aftermath of the Ivy Mike explosion was truly apocalyptic. The island of Alujulab, where the test was conducted, simply vaporized, leaving a giant crater 1.9 kilometers in diameter and 50 meters deep. The powerful shockwave and waves up to 6 meters high crashed onto neighboring islands, wiping out all life in their path. Vegetation was completely destroyed, and the soil on many islands became uninhabitable for years to come. The report to President Eisenhower on the results of the test stated, "The island of Alujulab is gone." And one might think, the United States had already created the most powerful and terrifying weapon for the second time. Is it possible to surpass this? Practically impossible, considering the time, but it turned out to be possible. The most powerful explosion on Bikini Atoll would occur on March 1st, 1954. As previously mentioned, this date would later be known as the Day of Remembrance for victims of nuclear tests. The United States would detonate a hydrogen bomb named Castle Bravo. The bomb was a cylinder 4.5 meters long and 1.35 meters in diameter. For the first time, the Americans used lithium deuteride as the thermonuclear fuel, encased in a natural uranium shell. The explosion's yield exceeded the calculated power by 2.5 times, resulting in 15 megatons. The mushroom cloud rose to a height of 40 kilometers, with its cap expanding to 100 kilometers in diameter. The explosion completely vaporized the island where the device was located, partially destroyed 2 other islands, and left a crater 1.8 kilometers in diameter. 72 hours before the test, the command received information that the wind direction had changed toward inhabited islands, but they did not cancel the test. The radiation plume moved toward Ringarook Atoll, where Bikini residents had been relocated, extending over 500 kilometers. In some places on the islands, radiation levels reached 1,000 roentgens per hour, with 600 roentgens considered a lethal dose for humans. On March 2nd, American military personnel were evacuated from Ringarook to Kwajalein, suffering radiation exposure between 70 and 100 roentgens. A layer of radioactive dust 2 centimeters thick fell on several islands. The islanders were not informed of the danger of the tests. Children played in the radioactive dust until signs of contamination appeared: severe vomiting, weakness, and hair loss. 2 days later, the U.S. began evacuation and medical assistance. Residents of Rongelap, Ringarook, Eilingin, and Utrecht were exposed to radiation. In addition to the Marshall Islands residents and the military, Japanese fishing vessels were also affected. The story of the trawler Fukuryu Maru inspired the novella Ashes of Bikini, written by author Arkady Strugatsky. The gray, misty veil enveloped the sky from the west. It slowly spread toward the rising sun, blurring and absorbing the clear line of the horizon, standing as a dense curtain between the eyes and the emerald sky. But it was not a fog. A few minutes passed, and fine whitish dust began to settle on the deck, on the nets, on hands and shoulders. It fell silently from above and covered the ship, swirling in the lazy warm waters of the ocean around the schooner. There was more and more of it, until nothing could be seen but masses of slowly falling powder, resembling rice flour. And this powder was hot. Radioactive fallout settled on a vessel located 170 kilometers from Bikini Atoll, with the layer reaching a thickness of 1 centimeter. All crew members received a radiation dose of about 300 arads and became disabled, while the radio operator, Aikichi Kuboyama, died 7 months later from liver cirrhosis. A total of 856 Japanese fishing vessels, carrying about 20,000 people, were affected to varying degrees, and 50,000 tons of fish were destroyed. This incident did not lead to significant political consequences. The United States paid compensation to the surviving crew members of the Fukuryu Maru, and Japan received compensation amounting to over $13 million. According to independent reports, more than 1,000 residents of the Marshall Islands died from cancer and other illnesses related to radioactive contamination. Women began giving birth to radiation-affected infants. After relocation, which was often conducted forcibly, the former population of Bikini faced starvation. In the 1960s, the United States informed the residents of Bikini and Rongelap that they could return home. Background radiation had fallen to normal levels, but the soil, plants, fish, and fruits continued to be contaminated. In 1978, the population of Bikini was evacuated once again, and a few years later, so were the residents of Royalop. As for the relationship between the United States and the Marshall Islands, in 1986, the parties signed the Compact of Free Association, recognizing the republic's independence while maintaining American military bases on its territory. More than a third of the Marshall Islands budget consists of payments from the U.S. under the Compact of Free Association and compensation for nuclear testing damage. In 2000, Nukes Atoll received $340 million from the U.S. government. In 2010, scientists from the Hiroshima Peace Institute, after studying documents declassified by the U.S., reported on the global consequences of the Castle Bravo tests. Over the next 4 months, radioactive ash was detected at 122 meteorological stations worldwide and dispersed over almost the entire Pacific Ocean, East Asia, Australia, North America, and the northern part of South America, the Caribbean Sea, and even Africa. The tests at Bikini Atoll made it clear that war had changed forever. After the destructive tests at Bikini Atoll, the United States shifted its attention to a more accessible and strategically convenient location, the Nevada desert. This region became the epicenter of a new phase of nuclear experiments conducted within the continental United States. The Nevada test site offered a unique opportunity. It allowed for the testing of new types of nuclear weapons and the study of the effects of explosions on infrastructure, equipment, and even people in close proximity. It was here that the era began in which nuclear weapons became not only symbols of military power, but also tools for scientific discoveries, sometimes teetering on the brink of ethics. In August 1949, the USSR conducted its first nuclear tests, which deprived the United States of the advantage of being the sole possessor of nuclear weapons. At that time, the US proposed the development of a thermonuclear bomb, which was believed to restore the US's lost position in the nuclear arms race. In 1950, the U.S. Atomic Energy Commission approached the Department of Defense to join in the development of a continental test site project. After considering several options, the military chose Nevada, a location where, downwind within a 200-kilometer radius, only 4,100 people lived at the time. Furthermore, the site's location offered room for error without endangering the population. The contracted team proposed 2 sites, designated as Northern and Southern, that met the primary criteria. In mid-November 1950, President Harry Truman tasked the National Security Council with overseeing the final search for the test site location. Specialists from the Los Alamos National Laboratory involved in the search selected the southern site. It was noted that the area's low population density allowed for minimal efforts in site control, and a government airbase located 29 kilometers from the site could accommodate up to 1,000 people. Additionally, scientists claimed there was no predictable radiation hazard for testing devices with a yield of up to 25 kilotons. Moreover, they allowed for the testing of bombs with yields of up to 50 kilotons. On December 18th, President Truman agreed with the specialists' arguments, and on January 11th, 1951, he approved the first series of tests. That same day, residents of the surrounding areas noticed flyers warning of impending explosions. From this day forward, the United States Atomic Energy Commission is authorized to use a portion of the Las Vegas test site to conduct tests necessary for the atomic weapons development program. Tests will be conducted on a regular basis for an indefinite period. Excerpt from the flyer. The indefinite period lasted 41 years. The Nevada test site became the primary location for nuclear testing in the United States. While 126 devices were detonated in other parts of the country by 1992, more than 900 devices were tested in Nevada. In particular, in 1953, the test site, which covers an area of about 3,500 square kilometers, witnessed the first ever test of a nuclear artillery shell. The towed M65 cannon, with a 280mm caliber and nicknamed Atomic Annie, fired the Grable shell. The 15-kiloton shell was launched over a distance of 32 kilometers and detonated 160 meters above the ground. But let's focus on one of the most significant operations within the Nevada tests. Early in the morning of January 27, 1951, an explosion shook the western United States, about 100 kilometers from Los Angeles, lighting up the Mojave Desert brighter than the midday sun for a few seconds. There, at the newly opened Nevada test site, Operation Ranger began, the first series of nuclear tests in the escalating arms race. Over the following decade, countries involved in the Cold War detonated several hundred nuclear devices in the atmosphere, continually increasing the yield of warheads and eventually covering the entire planet with a radioactive cloud. The effects of these explosions are still felt today. Traces of global radioactive contamination can easily be found in any living organism, including newborn children, in whose unerupted baby teeth scientists have found strontium-90, a radioactive isotope that does not naturally occur. You feel the wave of heat from the blast, and the light spreads all around you, recalled half a century later Frank Farmer, a U.S. Marine Corps veteran who participated in the secret nuclear tests. It gets so bright that you can see right through yourself. You can see the bones in your hands. In the 1950s, as part of the team aboard the floating workshop, Hooper Island, Farmer participated in the preparation, organization, and aftermath of over a dozen nuclear tests. To be precise, 35 detonations, each of which could easily wipe a decent-sized city off the face of the Earth. Frank personally witnessed 18 detonations, sometimes from a distance of only a few kilometers. And this was without any protective gear. At the time, little was known about the destructive effects of radiation on the body, and the operations were highly classified. It wasn't until many years later that Harper realized he and his fellow soldiers were essentially being used as test subjects. Like several tens of thousands of American and Soviet military personnel, their health was compromised due to nuclear testing. Up to a third of those who witnessed experimental blasts later became disabled, and many had children with developmental issues. The nuclear frenzy was in full swing, and on the other side of the planet, the USSR was trying to keep pace. A semblance of control over the nuclear arms race was achieved in 1963 when the treaty banning nuclear weapon tests in the atmosphere, in outer space, and underwater was signed in Moscow. The test site became the location for the first underground nuclear test. A Mark VI bomb with a yield of 1.2 kilotons, named Uncle, was detonated on November 29, 1951, at a depth of 5.2 meters. 6 years later, a fully contained underground explosion was carried out in one of the site's tunnels. On September 19, 1957, tests of a 1.7 kiloton device were conducted that did not produce radioactive fallout. In total, until 1992, 928 underground nuclear tests were conducted at the Nevada test site. This number of underground blasts was partly due to the treaty banning nuclear weapon tests in the atmosphere, in outer space, and underwater, which forced testing underground. Initially, the treaty, signed in 1963, included the USSR, the USA, and the UK. If the initial tests in Nevada caused limited concern among local residents, discontent grew over time. It is estimated that between 1986 and 1994, 536 demonstrations involving nearly 39,000 protesters were held near the site. In 1992, an 11-day protest involving 2,000 people took place at the site. Organizers demanded an end to nuclear testing. In September of that same year, the Nevada test site conducted its last series of tests as part of Operation Julian, which included 8 underground nuclear explosions. On September 23rd, during the Divider test, the last nuclear explosion of the 20th century carried out in the United States took place. In October, President George Bush signed a moratorium on nuclear testing in the United States. During the early tests in the 1950s, the public reacted to nuclear explosions with interest and even admiration. Spectators gathered on nearby hills to watch the famous mushroom cloud rise into the sky. Nearby cities, like Las Vegas, turned this phenomenon into a tourist attraction, selling atomic cocktails and hosting parties with views of the explosions. However, the romance of nuclear testing soon turned to alarm. The consequences of the explosions became evident. Radioactive fallout began to spread beyond the test site. Radiation clouds, known as fallout, settled on farmlands, wells, and rooftops. Local residents began to experience symptoms of radiation sickness, and cancer rates sharply increased. Communities living to the east of the test site, where the wind carried radioactive particles, were particularly affected. These areas became known as downwinders. Local people reported finding dead animals and observed strange phenomena like black rain. Many of them, including children, later developed thyroid cancer, leukemia, and other radiation-related illnesses. "We thought it was just smoke and dust. We didn't know it was death riding on the wind." In the 1960s, the active phase of the anti-nuclear movement began, bringing together scientists, politicians, and ordinary citizens. The focus of the protesters was on human rights and environmental protection. The Nevada Semipalatinsk movement played a key role, Semipalatinsk being a similar nuclear test site in the USSR that inspired global anti-nuclear initiatives. These efforts led to the signing of the aforementioned treaty banning nuclear weapon tests in the atmosphere, outer space, and underwater in 1963. However, as we know, underground testing continued until 1992. The test site turned the once desert landscape of Nevada into a radioactive zone. The tests left behind craters resembling lunar landscapes. Underground explosions caused cracks in the Earth's crust, and some of them resulted in the release of radioactive gases. The region's wildlife was also affected. Researchers recorded mutations in animals living near the test site. Many of us played in the radioactive ashes as children, unaware of their danger. Scientific research has shown that radioactive fallout from the test site reached other U.S. states and even countries beyond North America. Particles of strontium-90, cesium-137, and other isotopes were found in milk and food products, heightening public concern. The stories of people affected by the tests helped draw attention to the issue. One such figure was Dawn Chase, a resident of southern Utah, who lost several family members to cancer. Her story became the basis for a book and film dedicated to the victims of radiation. Stories like these increased public pressure on the U.S. government to provide compensation for those affected. Today, the Nevada test site serves as a reminder of the scale of the nuclear arms race. Tours are conducted on its grounds, where visitors can see craters and other test remnants. Meanwhile, scientists continue to study the long-term effects of radioactive contamination on health and the environment. In 1990, the U.S. Congress passed the Radiation Exposure Compensation Act, which provided payments to residents of affected regions. However, many consider these measures insufficient, and the number of claimants continues to grow. Nuclear testing in Nevada has become an important lesson for humanity, demonstrating the destructive power of the atom, not only as a weapon, but also as a source of environmental catastrophe. The history of the test site reminds us that scientific progress requires responsibility and thoughtful decisions. However, according to Professor Sarah Heath, a nuclear chemistry expert at the University of Manchester, it would be wrong to view the decade of atmospheric nuclear tests as something wholly negative. a black page in world history. In a way, it's a question of whether your glass is half full or half empty. In any, even the most negative experience, you can find something positive, she asserts. Yes, experimental nuclear explosions led to irreversible, sometimes catastrophic, consequences for many of those directly involved in the tests, and our planet was indeed covered with a dense layer of radioactive dust. However, those same explosions allowed for a number of critical scientific discoveries and gave rise to entirely new fields of knowledge. Some of these became a natural extension of the military experiments conducted. The most obvious example is nuclear energy. The peaceful atom is so named precisely because it owes its existence to the military atom. That is, nuclear weapon development and testing. According to Professor Heath, the construction of Calder Hall Nuclear Power Station, the first in the UK and second in the world, is a direct consequence of our attempts to obtain an atomic bomb. The bomb is when you release energy and allow it to reach supercritical levels, she explains. But in the process, you understand how this technology works and how to safely manage a reactor, so the same process can be used for energy production. The end of the nuclear testing era marked significant changes in the global order. The second half of the 20th century was characterized by an arms race, political rivalry between superpowers, and a growing awareness of the catastrophic consequences of nuclear war. However, amidst this chaos, a realization gradually emerged about the need to contain nuclear capabilities and protect humanity from their destructive impact. A true turning point came in 1996 with the adoption of the Comprehensive Nuclear Test Ban Treaty, CTBT. This document, signed by dozens of countries, aimed to completely halt nuclear tests. However, its implementation faced several challenges. A few key states refused to ratify the document. Notably, the United States, which actively promoted the treaty, has yet to ratify it, citing the need to keep its arsenal operational. Nevertheless, the treaty has become a symbol of the aspiration for a world without nuclear tests. Cultural pressure also played a crucial role in ending the tests. Filmmakers, artists, and writers began to highlight the nuclear threat. Films like Dr. Strangelove and literature on nuclear war shaped public opinion against testing. In the 1980s, nuclear disarmament movements emerged. Hundreds of thousands of people worldwide participated in demonstrations demanding an end to the arms race. Although politicians told people that this was done for their benefit, questions arose about the sincerity of the great powers' intentions. Politicians often claimed that nuclear arsenals were a guarantee of peace, but for many, the tests remained a symbol of fear and potential annihilation. The energy from these movements pressured politicians to rethink their approaches to nuclear weapons. While officially nuclear testing has nearly ceased, the threat of its resumption remains. New geopolitical conflicts and technological developments raise concerns. For instance, in recent decades, North Korea conducted a series of tests to demonstrate its nuclear capabilities to the world. Nevertheless, most countries adhere to a testing moratorium. Modern technologies allow for explosion simulations on supercomputers, making actual tests less necessary. The end of the nuclear testing era is not only the conclusion of one of the most dangerous processes of the 20th century, but also a sign of a shift in global thinking. Humanity has realized that it's not just the survival of individual countries, but the existence of the entire world is at stake. The suspension of tests and experiments, although not full disarmament, served as a step towards a safer world. The question is whether we will be able to maintain this balance, or if history will once again take a step back.